Hello everyone, in this video let's discuss how to design the Huffman coding in the data structures and algorithm. So if you see, there will be a given length of the bits. So using this one only we will be framing the Huffman coding for each and every letter or the each and every alphabet right here. So what are the characteristics of the alphabets we are having? Let's make a table here. So the characteristics I am having is, I am having A, B, C is there, D and E. So these are my 5 characters. Let's write the frequency count of them. Frequency count. So frequency count means how many times each character has been repeated in the given sequence. So A, 1, 2, 3, 4. So A has repeated 4 times. Next B, 1, 2, 3, 4, 5, 6, 7. So B repeated 7 times. Next C, 1, 2, 3. So C has repeated 3 times. Next let's go for D, 1, 2. So D has repeated 2 times. Next E, so E, 1, 2, 3, 4. So E has repeated 4 times. So here let's write the Huffman code. Let's write Huffman code. So to write this Huffman code, first we must design the Huffman tree. So let's design the Huffman tree, then let's write the Huffman coding for each and every character. So Huffman tree. Now what I must do is, I must see the frequency count and arrange the characters in the increasing order of their frequency count. So if you see here, first 2 will be coming. Next it will be 3. Next 2 times 4 is coming. Next it will be 7. So now write the respective character. So for 2 it is D. Next for 3 it is C. For 4 you can write A first or E first. So anything you can write. A, E. Next 7 is for B. Now the step is find the least 2 frequency count. So these two are having the least frequency count. This is having 2, this is having 3. Now combine them. So this is 2, this is 3, which belongs to D, this belongs to C character. So if we combine them, it will be 3 plus 2, 5. 3 plus 2, 5. Now what you will be doing is, instead of 3, 2 and all, so you will be writing 5 in the combination of D and C. So in the combination of D and C, 5. So next step also what you must do, you must rearrange them in the increasing order. 4, 4, 5 will be coming here in the combination of D and C. Next here 7 will be with the B. Now these two are having the less frequency count. So what I will be doing, 4 and here also 4. So this belongs to A, this belongs to E. 4 plus 4 will be 8. So if you see here, when you go from left hand side towards the right hand side, the frequency count must increase. Frequency count must increase. If you see here 2, 3, 4, 4, 5, 8. Like this the frequency count is increasing. When you move from left side to right side, the frequency count must increase. That one you should keep in mind. So instead of 4 plus 4, that is A comma E, I can write it as 8 now. Now let's arrange these 3 numbers in the increasing order. First 5 will be coming, next 7, next 8. So 5 is of DC, next 7 is of B and 8 is of AE. Now let's take the least 2 values, that is 5 and 6 of DC and B. DC is here, that is 5 is here. Next I must write 7. It must be in the increasing order of the frequency count when you move from left to right. So you can't write 7 here. So you can write 7 here in middle. 5, 7, 8. It is increasing now. So you can write here. Otherwise if you want to write here, it will be far away from the D and C which you want to combine. So I wrote here, 7 I wrote here, that is of B. So if you combine these two, 5 and 7, what will be the value? 12 will be the value. So now if you see, we are left out with 8 and 12. So 8 is of AE and 12 is of DC, 12 is of DCB. But I said frequency count must increase. But if you see here, 12 is here at the root node and here 8 is there. It is not in the increasing order. So what I will be doing, I will be shifting this tree towards this side. 8 will be here, 4, 4. This is of A, this is of E. Now if you see, the frequency count is increasing in the parent node. So the parent node or the root node, if you see, the frequency count must increase. Now what I can do, I can combine these two values, because since I am having only two values. 8 plus 12 will be of 20. So now we are completed with the Huffman tree. Now I must write the code. How to write the code? So if you consider this as a node, left subtree will be getting 0 and right subtree will be getting 1. So left subtree 0, right subtree 1. 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 Like this. Now let's write the code for each and every one. Now I must write the code for A. It will be 0. From 20 to 8 you came using 0. From 8 to 4 you came using 0. So 0, 0 will be the Huffman code for A. Next for E, 0, 1. For E it will be 0, 1. Next for D, 1, 0, 0. For D it will be 1, 0, 0. Next for C, 1, 0, 1. 1, 0, 1. For C it is 1, 0, 1. Now let's write for B, 1 and 1. For B, 1, 1. Now if you see, we wrote the Huffman coding for each and every character. Now you can find the total number of bits also. So how to find the total number of bits? I will show here. Total number of bits will be equal to frequency into number of Huffman code. Frequency into number of Huffman code. For A, if you see, frequency count is 4 into number of Huffman codes is 2. So 4 into 2 plus 7 into 2 plus 3 into 3 plus 2 into 3 plus 4 into 2. So if you find the value, 4 2s are 8, 7 2s are 14, 3 3s are 9, 2 3s are 6 plus 4 into 2. So here I forgot to write for 4 into 2 now. So 4 2s are 8. So 8 1s are 8, 8 2s are 16. 16 plus 14 will be 30. 30 plus 9 will be 39. 39 plus 6 will be 45. So we got the total number of bits used here, that is 45. So this completes the problem. If you have any doubt on the Huffman coding, please comment below. If you liked the video, please subscribe and support us. Thank you.